x. So we want to rotate the coordinate axis to eliminate x and y. Essentially what we have is these conic sections that are not going up, down, left, or right. So they're at angles. And we want to rotate them back so that they are actually on the xy coordinate plane. So they're either going, like parabolas are going to either go up, open down, open left, or open right. Because what they're going to give us is kind of a parabola that looks like this. It's going to be open into the side. Or it could be a conic, any of the others that we've covered so far, that are not going to be straight up and down. So they're going to give us the general xy, and we're going to remove it, because the coordinates that we have is kind of rotated this axis at an angle of a certain degree. And we want to rotate it back so that we get this equation here with no xy term. Now the key thing with all of this here is kind of using these equations here. And we've got these three, and these are all out of the book. And we'll be using them. So we kind of have ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. And we're really rewriting with our primes. X prime, y prime is just saying that it's a new, different x than what we started with. Or a different way to denote it. And the rotation, that way that we find this angle is cotangent of 2 theta is equal to a minus c over b. And here's the key piece, is that y is equal to x prime, make sure I write this correctly, cosine or sine theta plus y prime cosine theta. And x is x prime cosine theta minus y prime sine theta. And we're going to get our angle from cotangent and use these here to re-rotate the graph back to where it's supposed to be. So we'll look through some examples of these here. And this is the first one here. We want to rotate the axis to eliminate the xy term in the equation. Xy minus 1 is equal to 0. And then write the equation, and as always, we're not going to worry about sketching the graph. Now, if we look at this here, the first thing we really need to find is our angle. Cotangent of 2 theta is equal to b, or a minus c over b. Well, a is the term with x squared. Well, do we have an x squared term? So it's 0. Do we have a y squared term? So c is, and the value of b? Because b is in front of the, what term? xy. A is in front of x squared, b is in front of xy, and c is in front of y squared. So that's where we're getting a, b, and c. Now at this point here, we do need to solve this here. So cotangent of 2 theta is equal to almost, because we've got to take cotangent inverse first. Now cotangent of 0, because tangent's the same as 1 over cotangent. So if we want to do this with tangent, it wouldn't work too well, because we would be saying tangent of 2 theta is equal to 0 over 1, which is undefined. Well, the one spot that tangent is undefined that we can use inverses is cotangent inverse is at pi over 2, just straight up and down. Because if we think about cotangent of theta is equal to adjacent over opposite. Well, adjacent is always our x, and opposite is our y. So we're looking for an angle when x is 0 and y is 1, which is straight up, which would be our pi over 2. Questions on this here? Well, now we would divide both sides by 2 over you're good, which would be any questions on how we got the angle? We feel pretty comfortable with this here. Also, in your graphing calculator, if you hit catalog, so it should be, I think, it's either going to be second or it should say CAT. The second 0, because it says catalog right there. Then hit PRGM program, the button that says that, because that'll take you down to C's. And scroll down because we want cotangent inverse. GOT, because they put them all in cotangent inverse. Yep. So it doesn't look like, yep. For some reason it doesn't have it, but some of the graphing calculators will let us do cotangent inverse. But for some reason this one doesn't have it. So, any questions on how we found this angle pi over 4? Okay. So our angle is pi over 4. Now so we're wanting to find the angle. Now we're going to use these here to define x and y. Now x is going to equal x prime sine of pi over 4 minus, I got them switched. It's going to be cosine of pi over 4 minus y prime sine of pi over 4. Now pi over 4 is square root 2 over 2, because that's our 45 degrees. So this would be square root of 2 x prime over 2 minus square root of 2 y prime over 2. Or we can just really combine those and say x is equal to square root of 2 x prime minus square root of 2 y prime all over 2. Questions on any of this here? Okay. Move him down here for a second. Erase all this here. Set him right here. Because we also need y. Because we need our x and y. So what we have is x prime sine of pi over 4 plus y prime cosine of pi over 4. Well, that's not really changing. We're going to end up with square root of 2 over 2 x prime plus square root 2 over 2 y prime, which really just tells me y is the square root of 2 x prime plus square root of 2 y prime all over 2. Any questions on any of this here so far? Not too bad. We found the angle by using cotangent of 2 theta is equal to a minus c over b. And then we plug that into our x and y to define x and y, essentially with that rotation, and we're taking it into account. So we needed the angle to define x and y. We're going to use x and y to eliminate x, y in this equation. Now we define x to be what? And y is almost the exact same thing, except we're addition instead of Almost, but
So close.
well, this is considered to be the difference of perfect squares because I have the same two things in either spot and the sign in the middle are opposite. So a minus b times a plus b is a squared minus b squared. And we can do this multiplication out. So 2x prime, square root of 2x prime times square root of 2x prime, well, square root of 2 times square root of 2 is 2, and we have x prime squared. And then we would have, well, minus 2 x prime y prime, going from here to here. Now, if we do the middle one, or not minus, this would be plus, positive and positive.
The next one would be
The next one would be our negative. And then lastly, we would have negative 2 y prime minus 1 is equal to so really what we have is 2x prime, not 1, x of 1, 2 x prime squared minus 2 y prime squared all over 4. Let's add the 1 to the other side. Starting to look like an equation we're familiar with. Well, 2 divided by 4 and 2 divided by 4 becomes 1 over 2, yes? And I'm going to split this back apart.
oh, hey. Recognize this.
And that's your answer. Questions on this here? We good with this here? Okay. Why don't we look at another example? Because that was a ellipsis, not ellipsis, a hyperbola equation that we were given. You will have one of those on your homework. What we're going to look at next is a hyperbola. We're going to do the exact same thing. So we need to find our angle first. Cotangent of 2 theta is equal to a minus c over b.
13 over 6 squared root.
Yeah, it is b.
C
C over b. Yeah. Our two squares, x squared, y squared numbers, coefficients are on top. The xy term's coefficient is on bottom. So you had it right, it is b. Negative 6 square root of 3 is b. So we can simplify this here. Cotangent of 2 theta. Well, 7 minus 13 is? We can say square root of 3 over. Actually, let's leave it as, I'm going to leave it as 1 over the square root of 3. Because this one here works out nicely, because I can change it to tangent of 2 theta, which would just be the...
Square root of 3. I was right, I just was a step ahead.
So at this point here, luckily with this one, we can find out what tangent inverse of square root of 3 is. 60, which is pi over 3.
All of these.
Mm-hmm. Now, will it be wrong to use degrees? As long as you're converting your sine and cosine in degrees. Then we would divide both sides by 2, which tells us that we have pi over 6. So our angle for this here is pi over 6. Questions on any of this here? Okay. Erase all that. X is equal to x prime cosine of 6 plus, not plus, minus prime of 6. Now we can type that into the calculator. Sine and cosine of pi over 6. And if we type cosine of pi over 6 into the calculator, we get it should be square root 3 over 2 or 1/2. Which means we have y prime over 2. Because I do have trouble keeping it straight because I know pi over 3 and pi over 6, we have square root 3 over 2 and 1/2 are our two angles. So here we have square root 3 x prime minus y prime all over 2. Now I have to do the same thing with y. So with y is equal to sine pi over 6 plus cosine of pi over 6. Now luckily, it was kind of already told to us. That cosine of pi over 6 is square root 3 over 2. Sine of pi over 6 is 1/2. Any questions on this here? Before I move these up here, because I'm not going to have the same space. Because again, just like we did on the previous one, we're going to do the same thing. We're going to replace x and y with these here. Don't look too excited. Because what we're going to have is 7 times square root of 3 x prime minus y prime over 2 squared minus 6 square root of 3 square root of 3 x prime minus y prime over 2 times x plus square root of 3 y prime over 2 13 x prime plus square root 3 y prime over 2 equals 16. I went on and just added the 16 to the other side. We'll deal with it later and kind of how all that works together, but I'm just moving him over there. Now, out of all these here, this one's going to be the nicest one to multiply together. Because as we saw already, hey, numerator is the difference of perfect squares, so that means it's really going to be the first term squared minus the second term squared is what's going to happen. Because for our a plus b times a minus b, the middle term canceled out, just like the previous one. Because our xy, for where those cross over, will always cancel out if we have the same a, b, b, but we don't. But the middle term will essentially cancel, and we'll see it. So it's going to work a little bit nicer. I got ahead of myself. Now, if we do this first one here, the denominator is going to be 4. is 2 squared is 4. Now, when we square the numerator, well, square root of 3x prime is going to be 3 prime squared minus, so times itself, we've got to do the middle cross.
That would be plus.
Because, well, square root of 3x prime times negative y would be negative square root of 3x prime y prime. And we'll have it going the other way. 2 square root of 3x prime y prime. And then minus, well,
Same thing. Or plus.
it's minus and minus is going to be y prime squared. And this is just coming from, in a general sense, a minus b times a minus b, or we would get a squared minus ab minus ab plus b squared. So a squared minus 2ab plus b squared. Where x in our case is the square root of 3x prime. Square root of 3 squared is 3. Then we have x prime squared. Now the middle term, we're going to have two of them. A is square root of 3x prime, b is y prime. And it is negative because of the subtraction property. Negative and negative make a positive, and we have y prime squared. Does this make sense of where we got all these numbers from? Yeah. And I mean, if you need to write out that in full multiplication, do it. So go on and rewrite this entire parenthesis by itself, multiply it, and do the whole steps out. Does that make sense? If you have questions, ask, and I'll step back through it. Or do you want to see that multiplied all the way out? Because we can do it. I don't mind. Because really what we're saying is 7 times so 7, because we still have 4 on bottom. Square root 3 times square root 3 is 3 x prime squared. Well, then we have, I'm going to go on and write 2, because these here are going to be the same. So this here, I'm still skipping steps, I can stop it. We would have this. From here to here. From here to here, we would also have the same thing, which gives us. All right. And lastly, you're welcome. But we're still going to have a denominator of 4. Now here, square root of 3x prime times x prime is going to be the square root of 3 x prime squared. And then we would have square root of 3x prime times square root of 3y prime is going to be plus. I'm going to write this out because of the sign change. It'll make things a little weird. Because these here give us this. However, I have negative y prime times x prime, which will be negative x prime. They're not the exact same, so I can't use that little trick. Minus y prime squared. But we can't combine those middle two. And we'll have 2. Yep. Because in the normal method, it should have been minus 2, but here it's going to be plus 2. Because A and B, A's aren't the same, B's aren't the exact same. So any questions on anything we've done so far? Okay. I've got to move him down, but we're not finished. because we still have the plus 13. So now this here is going to be the exact same as the first one in property, because we'll have x prime squared plus 2 square root 3 x prime y prime plus 3 y prime squared all over. Now this works along the same properties as what we did with the first one. It's just that now it's plus, so the middle term is positive. Any questions on any of this here so far? Okay. For space sake, I'm going to erase him here. Put that down. Come on. Move him in here. So we have all of this here. Yes? Now, and this is still all equal to 16. I just don't have the space to write it. I'm going to go on and multiply through by these three terms. 7 times 3 is going to be x prime squared minus 14 square root of 3 x prime y prime plus 7 y prime squared minus, well, square root of 3 times square root of 3 is 3 times 6 is x prime squared.
12 square root of 3.
And then negative and negative make a positive, plus 6 square root of 3 prime squared. 13 x prime squared plus 26 square root of 3 x prime y prime, and then plus 39 y prime squared. So let's look at the x prime squared. I've got 21 minus 18. Well, 21 minus 18 is what? Plus 13 is x prime squared. So I'm going to mark out him, him, and him, so I can keep track of that. Now let's do the middle, the x prime, y prime. 14, negative 14 square root of 3 minus 12 square root of 3. Or negative 26. Negative 26. Those are gone, which is what we wanted, because we wanted those to go away. 7 square root of 3, 39. Let me make sure. Yep. We should have a square root of 3. No, because when I look back here, so again, just paying attention to what this here, because what that changes is when we come over here, since that has a square root of 3, here, so negative and negative make a square root of 3, and square root of 3 is 3. 6 times 3 is
Got rid of those, remember?
so 7 plus 18 is plus 39. As we said, this is all equal to 16 divided by 4. $64 divided by 4.
16.
This looks familiar, doesn't it? Because we said this was a ellipses, yes? Ellipses always equal.
That's 1, 4, and then
And that's it. Now, doing this on paper is not going to be as huge as this is here. Partially due to the fact that your pencil lead is not even a tenth of the width of this here. So you'll have more space to write this out. But again, just take it step by step, and these aren't actually as bad as they seem, because if you notice, most of the terms, especially our ugly terms with radicals, all canceled out. So we end up with this here. Questions on this here?
of course.
Now, there are some interesting properties with this because when we rotate it, we're taking out the b, x, y term. Yes? So, f and f prime, what our constant term is, if you notice, that never changed from what we started with to what we ended with. We ended up, we ended up dividing by 16, but even in the end on the last one, we still had 16 at the start and at the end. It didn't change. Our constant term doesn't change. A plus C is still going to be A plus C. One more. 7 plus 13 was 20. Because when we get down here, because it wouldn't be in this form, we're still here. 4 plus 16 is still. So we still get those same values. And here, so b squared minus 4ac is still going to be b squared minus 4ac with our primes. But what do we know about b prime? It's gone, because we were trying to get rid of it. So really, this last part is going to change. And that's kind of what it's going into this here, the fact that we're trying to get it to be 0. So really, b squared minus 4ac is equal to negative 4a prime c prime. And kind of talking about the discriminant in quadratics. So we come across these here, these properties. Now, if b squared minus 4ac is less than 0, it's going to be either an ellipses or a circle. If b squared minus 4ac is equal to 0, then it's a parabola. And if b squared minus 4ac is greater than 0, then it is a hyperbola. For example, we have this here. So a is 3, b is 7, c is 5. We get negative 11. Since negative 11 is less than 0, the graph is an ellipse or circle. Now at this point here, there is equations and processes that we can go through, and I kind of removed them here from actually figuring out what it is. And really what they're going to do is they're going to take this equation here and get y by itself, essentially solve it for y and graph it. Now, part of the assignment that I'm going to have you do, I'm not going to have you go into the particulars of that, especially where we're at in the year. What you can do, especially if it comes out to be this case, because b squared minus 4ac is less than 0, you can type this thing in here, just like we have it into Desmos graphing calculator, and it'll graph it for you. It doesn't care that y isn't by itself. So you can do 3x squared to do the squared at shift 6, or a little caret key. this symbol, we'll do powers, and you can type this in. Hit enter and it'll graph it. And if it's ovular, then it's an ellipse. If it's circular, it's a circle. And that's it. Yep, that's all we're doing. Now for these here, we can use the discriminant. So here, b is -3 squared minus 4, a is 2, c is 2. Well, 3 squared is 9. 4 times 2 is 8, times 2 is, which gives us -7. So this is either a circle or an ellipses, and we'll see which one it is here in a minute. So the next one, -6 squared minus 4 times 1 times 9 minus, and this here is a, this is a parabola. Parabola is equal to 0. Hyperbola is greater than 0, which most likely so 1248. So this here would be a hyperbola. So, and they go through the calculations, see, they're trying to get y by itself, is what their goal is, and manipulating it. But if we graphed it, it would give us this here. Okay, it's a ellipse, because that's definitely not a circle. We can do the same thing with the middle equation for b, and we get a parabola. As you can see here, it is tilted. It's not going straight up, down, left, or right like we're used to. And the last one is a hyperbola, because we do have two parabolas going in opposite directions, and that's it.
Oh, wait, what? I skipped a page. Dang it.
Now, the homework. On 13, 17, and 21, we didn't do one of each type because there's not going to be any circles. I'll tell you that much right now. It's going to either be an ellipse, parabola, or hyperbola on these three here. So we're doing the processes that we did to get the equation. Okay? We didn't cover parabola, but it's going to be the exact same process. Does that make sense? You can find a seat. A sec. Come on. No, it doesn't. You're welcome. I found it.